Hey there, welcome to Broadcast to Post. I'm Jeff Sengfield, CTO at Keycode Media. This is the show where we interview leaders and experts in the AV, broadcast, and post-production spaces. We're giving you the inside tips to grow your media workflows and business today.
Welcome to Broadcast to Post. I'm Steve Dupay. Cloud and cloud hybrid workflows became an absolute necessity over the past few years. Now engineers and managers are at a crossroads, trying to determine which aspects of their production to keep in the cloud, which to move back on-prem, and how to mush both into a cohesive hybrid workflow. We're lucky enough to be joined today by the CTO of Ross Video, Troy English. Troy is going to discuss the front row seat he has to innovation at Ross Video and the unique way customers are adopting new technology and new workflows. Before we get started, it's worth mentioning Keycode is a top-tier partner of Ross Video, installing systems across the country. Well, Troy, it's great to be able to talk with you today. There's a lot to cover, and I think we ought to just dive right into it.
Sounds great. Thanks, Steve.
So one of the things that always confuses people is, what do we mean by specific terms? For example, what do we mean by on-prem? What do we mean by cloud? What really is hybrid? Can you maybe take us through some of those definitions? What do we really mean by on-prem?
So on-prem stands for on-premise, which essentially at its core means that the equipment you're using is in your physical location, or a physical location that you're renting or owning. Different from, of course, cloud, where typically that means the equipment that's doing your video processing, audio processing, et cetera, is not actually yours typically. It'd be more something in an AWS, a Google, an app, that sort of thing. Okay. So on-premise usually just, you own, it's on physically with you somewhere.
And that would kind of include things within the physical building itself, maybe a small campus kind of location, something that's physically adjacent to where you're working.
Well, I wouldn't say adjacent, because that's okay. because REMI, right? We haven't talked about REMI versus cloud production, but it usually means that the equipment is physically somewhere that you have access to. So, trucks are a good example of on-prem as well, because a truck isn't a premise, but on the other hand, it's still, you have the physical equipment. And it's interesting because if you compare it to cloud, for example, it can still be the same kind of processing power you use in the cloud, an x86 computer, but it's your x86 computer that right. You can actually, someone that works for you can go touch it. I think is the easiest way to say it.
That's a great definition. If you can get at it and mess with it, then it's on-prem.
Yeah. Yeah. And when we contrast it to cloud, the funny thing about cloud is, you can still even have your own private cloud. Like some people build their own cloud infrastructure, which is on premise, but we're splitting hairs there. So it's easiest to not worry too much about that.
Okay. And what do we mean by a hybrid?
Sure. So hybrid is when you want to do a bit of both. So we haven't talked too much about what cloud processing production means yet, but if you have some cloud processing and some on-premise equipment, and in our case, I would also say, generally speaking, from a live production standpoint, where you're actually bridging them with video and audio signals. So you're doing a production with some equipment that's in the cloud and some equipment that is on-premise. And that hybrid is, I think, one of the more attractive, certainly, and for the next number of years, way that people will actually be doing their productions, as opposed to either all on-premise or all in cloud.
One other one that I think kind of needs to be cleaned up a little bit, definition-wise, and you alluded to it, is REMI. Why isn't cloud the same as remote?
Well, sure, because REMI usually just means, the simplest definition is that the people operating the equipment, or some of the equipment, because you can, again, have some REMI, some not for your production, are not like adjacent to the production equipment. So a good example of REMI is, and you don't have to be cloud to be doing that. So you can have all of your production processing power in the cloud, in which case you're by definition REMI. Like if you're doing cloud, you're REMI, because your operators are obviously not sitting in a basement wherever AWS is hosting their servers. And of course, the traditional view of production would be that you have a rack room and then a floor nearby, typically, or even next door. Sometimes you have your control room, And if you wanted to, your control room staff could run over again and get physical access to that equipment. Whereas you can still have on-premise equipment and do REMI, because maybe all of your physical equipment is in Washington, D.C. You've got a big, server farm, that's all your production rooms there. But your actual operators, maybe some are in Boston, some are in Seattle. So they're accessing the equipment remotely, because REMI just stands for remote, right? That's a short form. But they're still accessing on-prem equipment. So because you're doing REMI, doesn't mean you're doing on cloud. It doesn't mean doing cloud production. REMI just means the people who are doing your production are not in the same physical location as the equipment that's processing the video, audio, metadata.
Great definitions. I think that's one of the things that people get kind of confused about, and having that cleaned up, I think is fantastic. Take us through what cloud processing really means. Are we taking that physical gear that we're used to having in our facilities, in our truck, and are we putting that in a data center, or are we doing something different there?
Sure. So let's talk about cloud in a couple of ways. I mean, Cloud in broadcasting has been used for quite a number of years. This is not like just this last couple of years. For example, newsroom control systems, asset management systems, those kinds of products have been in the cloud for quite some time, 5, 8 more years, I'm sure, with some vendors. So what we're really going to talk about today and focus on today aren't those aspects of it, but for production, which means if I'm going to have equipment that sits in the cloud that is processing a video stream, an audio stream, obviously the sources for those, of course, are local somewhere, generally. So when we talk about cloud production, we're talking about the shift. And again, Ross, we concentrate on live production as opposed to post-production. So again, people have been doing post-production in the cloud for quite some time. So really, we're talking about live video streams and live audio streams. If you were doing a sports event, for example, and the only thing in that sports event are the cameras, and those cameras are going into a cloud of someone's, and then in that cloud is where you're running the software that is like a virtual production switcher, a virtual audio mixer, and then of course all the other sorts of features like watermark encoding for advertising, etc. So when we talk cloud for today's conversation, we're really talking about the live production version of cloud.
So one of the ways that I think I interpret that is that it is the virtualization on standardized equipment that enables us to have the same functional processes as what we'd have on instantiated hardware on premises. But with it being virtualized, it can run on common equipment in the data center, in the cloud, and not have to be unique equipment. So literally, we're using the same services that a cell phone service company might provide, or that a data mining group might use in the cloud. Correct?
Close, and this is where we start getting pedantic and splitting hairs. And since my background is software pedantry, I guess comes with that's what it's like. You can, of course, take the same software that you run in the cloud and, generally speaking, run that software on a piece of equipment that you owned on-prem as well, because it's software running on, generally an x86 machine of some kind. So when we say cloud processing, I wouldn't say that it's the ability to run it on what we think of as common off-the-shelf compute platforms, because you can do that on-prem as well. That doesn't have to be in the cloud. So when we say cloud processing, we specifically mean running software, which is, yes, that software does run on, that kind of compute processing. But additionally, you're not running it on equipment that is on-premise, but you're running that software in a cloud provider and not your own physical hardware.
Perfect. Well, I think that takes us right to the main topic here is hyper-converged infrastructure. What does that really mean, and how does that work for us?
Yeah. So today, I love the timing of this because the recording of this conversation was thankfully 2 days after we made a new announcement. So we've been really working really hard and creating something which has never been seen before, which is what we call our hyper-converged platform. And this is an on-premise solution. And what it really means is, if you take the thought experiment and you say, Well, if I take all of the processing that I do for video and audio and the metadata, the closed captioning and such, and if I put as much of that as I can into the same piece of equipment, what does that actually do? And on the surface, it's like, well, okay, I get fewer power supplies, maybe it's a bit smaller, but it's far bigger than that. What it really means is an insane reduction in complexity, and everything that you start caring about, it's not just complexity, it's size, it's the power to run the equipment. And then one of the things that it's funny, David likes to say is after talking to a lot of people, there's nothing engineers in television stations and other places hate more than cables. They despise cables because cable management, you got to run thousands of these things. And when you actually do something that's hyper-converged, it's a massive, massive reduction in cables. And with that reduction comes a lot of really interesting things. So, and I'm going to try not to sound too much like a sales pitch. It's just the problem for us is we're super excited about this. We've been working on this for years. This is not a new thing. We just got to announce it yesterday. So we just got to announce something we call the Ultrix FR12. The 12 just means 12 rack units. That's how big it is, roughly so big. But in that, it's got flexible I/O, right? So it takes 2110, it takes SDI, it takes fiber on inputs and outputs up to 288 squared at UHD, 12 gig rates. And you can mix and match any input, any output. So all that normal, you might do conversion externally sometimes, SDI to 2110. Well, that's just built in because the system takes it from the I/O, converts it down to video, ships it around. So it's independent and the system doesn't care what you bring. And then we added in a ton of the functionality that traditionally you would actually have individual components for, right? And you'd have to cable from the router into that equipment and then back to the router, and you have all of these loops everywhere. So audio, it's got a 6,000 squared audio matrix in the middle of it. And audio embed and de-embed. So you can take any video signal, de-embed the audio, and then there's some processing such as gain on every audio signal, 6,000, and then shuffle, right? So any audio mono channel from any source to any mono channel on an output. And historically, we've had people who buy Ultrix just for the audio embed, de-embed.
Right.
So you add that in, you put frame synchronizers on essentially every input, clean quiet on every output, and then you go farther. And then you're like, okay, well, what are the big things people use? We were talking to one client. This is actually a 2110 client about a year and a half ago. And they were saying that for their 2110 environment, just what they were doing, half of the 2110 signals they were doing were for multi-viewers. It comes out of the router, hits the multi-viewer. And of course, the multi-viewers, you need one signal for every pip. Right. And you've got lots of these things throughout your facility. That's a lot of signals. And so what we did is we put multi-viewers inside the same box. So up to 48 multi-viewers, which is, for most facilities, 48 multi-viewers and 100
lot of heads.
Yeah, and up to 100 pips per multi-viewer. I wouldn't do that. They're kind of small.
Wow.
But I usually, go for more 40 or 25, whatever makes sense for you.
Sure.
And all of the routing for that is independent in the box from all the inputs and outputs. So if you look at that 48 times 100, that's 4,800 cables, and they're all gone now, and the weight of them and the cost of them. And then we took our production switchers, which are another big consumer of sources, and we embed the production switcher into the router. So you can have an acuity switcher, which is our large one that's used often in like very large sports productions, or the carbonate switchers. We can actually put up to 8 carbonate switchers in the same box. And every switcher has access to every input and output. And again, independent of flavor. So all of a sudden you get SDI and fiber and 2110 for all of that. And once you've done that, so I have a cheat sheet here. The guys did an analysis. And what they did is they said, well, let's pretend somebody used every feature inside of this FR12. Unlikely, right? Nobody uses every single, but let's say used every single feature. What is the equivalent, system if you didn't use Ultrix and you did it in a more traditional manner? And it's interesting that traditional manner, by the way, would also apply to whether you're using, standard off-the-shelf processing, because a lot of the big thing you want to reduce is sending video from one computer to another computer, be it, an x86 based one, or be it, the more custom hardware that many of us make.
Right.
So the comparison was the Ultrix FR12 takes 14 RU, just so it's 12 versus 14, 12 RU for the processing box, and 2 RU for the power supply. So 14 RU. The equivalent in individual components, and we tried to be fair about this, right? We weren't trying to make it, something where someone would look at and go, wow, you just cheated, was 549 RU. And that's racks and racks and racks.
Wow.
Of equipment. And, we all want to be green, right? It's one of the big things in the industry. So the FR12, that location is 2,400 watts. And the equivalent in non-hyper-converged solutions would be 52,000 watts. It's a massive decrease. 576 cables versus 11,000 cables and 128 pounds. And this matters actually because a lot of people also travel with their equipment, right? Maybe it's a truck. We do have, you do meet the occasional person who actually flies equipment around. So 128 pounds versus 6,000 pounds.
That's tremendous weight. I know from past experience, 30% of the weight of a truck used to be the amount of cabling that they had to carry around.
Yeah.
And George Hoover, I think I'm sure you know George, former CTO of NEP and retired now. He used to say, you manufacturers, you all make switchers, you make routers, you make all this modular DAC, you make multi-viewers. Can't you take 2 or 3 of those and combine them together and get me one box? And it looks like you guys have got the whole thing all together.
Yeah. And and the funny thing also is, I always forget something, is we also have an audio mixer built in as well. 128 by 64, and there's lots of fancy stuff about you can subdivide it, et cetera.
Sure.
But the thing, because a lot of us, I used to have hair when I started in the industry, so I've been here a few years. And when I started, the first thing you'd see in any studio, when you'd go into doesn't matter what kind of studio, you'd see in engineering, there'd be a big, used to be AutoCAD drawing, right? It shows all the equipment, the interconnects. And it was very big and complex. And a lot of people are still building facilities that way. And when you look at something like hyper-converged, it changes the paradigm from I have to interconnect and send all this video. And this, by the way, doesn't matter if you're talking SDI or 2110. It's the exact same issue. It just happens in 2110 that you don't have an SDI router. You have got a router from, pick your favorite IT manufacturer. And if you can reduce that, you reduce massively, costs, weight, complexity, and you also reduce points of failure. You don't have to worry about how many, if somebody cuts the cables because cables aren't there. But right. I think weight is frankly one of the biggest things, and rack space. Because when we talk about cloud, which we haven't talked about too much yet, but one of the big things about cloud, of course, is, you can get more services and they don't take up more physical rack space. And that's if you're downtown New York, that space is critical, right?
Oh yeah, absolutely. There are buildings there I've dealt with where you couldn't physically get all the equipment under an old design on a single floor, and you were going 8, 9, 10 floors, and you're starting to get into the maximum length of cable runs for at 3 gig signals, and it's just crushing at 4K if you're trying to do 12 gig. So yeah, it becomes a real issue.
Yeah. So here at Ross, we're actually pushing heavily forward in both directions simultaneously. So we truly believe that with hyper-converged, it's very compelling for a lot of people, solves a lot of problems. And some of the issues people would have had before, I need to go to cloud because I don't want to rent another building. I'm not a physical space. That's true. But then you get the hyper-converged, and all of a sudden you get racks and racks of space back. So we're pushing really hard on that. And, we're very proud of it. We think that it's actually going to be a real game changer, especially now that we have the larger rack frame. But the same token, we also believe there's lots and lots of benefits to cloud. There's lots of reasons people go to cloud, and we believe strongly in those as well. And we have another team that's working heavily on cloud processing of everything, to be honest.
So you've got the physical gear hyper-converged into a very compact package, 12 RU for the gear, 2 RU, additional RU for the power supplies. What is the cloud impact going to be? What happens next?
Yeah, well, cloud is interesting because you go to cloud for different reasons, I think. So cloud, of course, has a lot of flex. I mean, one of the biggest things cloud gives you is obviously flexibility, right? Like you can get, a new virtual production switcher very quickly in the cloud. You don't have to wait for someone to deliver it. You don't have to rack it. You can just go on, to your cloud provider, start the service as long as you're licensed, and away you go. And cloud is also a great place. Like if you want to experiment with a new show and you want to do an hour a week, just to try it out, see what people like, see how things are. I mean, you can do that with cloud without having to go off and, buy a large, set of equipment, install it, wait for it to arrive. You can just start. You can dabble in it. And I think the other really nice things about cloud is the ability to flex. Right? When you buy hardware, you get a certain capacity, and if you want more capacity, we have to buy more hardware. And that's fine. And with something like an FR12, it's very cost effective, but it's still not, I guess you can always rent some hardware for a short term.
But it's still big CapEx expense for somebody, as opposed to a minimized OpEx. Yeah.
So good examples of hybrid are, if we talk about something like a television station, news, right? Elections.
Okay.
Yeah. Election season comes every 4 years in the United States. And for a lot of people, that means they really want to do a much more involved show, a lot more graphics, if nothing else. So you may want for 3-4 months, a lot more graphics engines. And if you have cloud and the ability to just say, for the next 4 months, I want to add a number of channels of graphics, and then I'll stop using them again. I mean, that flexibility has a ton of value. And physical equipment isn't as flexible, obviously, by its nature. And so that's one of the big advantages to cloud, of course, that flexibility. And that's where the hybrid comes in. We come full circle. Is you can have the hyper efficient, hyper converged solutions on-prem, but then you can flex in and out of the cloud either to experiment or Olympics. Olympics we do every 2 years, right? I can do my equipment for the Olympics, and I don't have to keep it. I don't have to buy it and keep it in a warehouse, frankly, for the next Olympics. And to be honest, sometimes if you buy equipment for something like that, you may find the next time you want to use it, it's 2 years out of date. I want to use something new. I did the last Olympics, in 3 gig, but this year I'm doing UHD, and the equipment I bought 2 years ago is still 3 gig, and it doesn't work. Right. So that flexibility that cloud gives you is great. And hybrid solution is kind of like take the because everything has pros and cons. Mm-hmm. So I can say, here's my pros and cons of on-prem. Here's my pros and cons of cloud. What if I don't take the cons? What if I don't accept the cons? What if I just say, I want the pros from on-prem and the pros from cloud and use those? Okay. And then the cons, I'm not going to deal with those because I'm going to use the one from the other. So that's what hybrid is about. And that's why we're pushing so hard for both solutions, is we really want to be able to give people all of the pros. And if we were doing just on-prem, obviously there's a lot of people that we're just not going to be able to make happy.
Right.
You're making people happy is what we want to do. It's actually one of the big drivers here is making our customers happy. And if I can't provide them cloud solutions, I'm not making them happy because of some of the downsides to physical equipment, and vice versa the other way. If I went all cloud and didn't take advantage of what things like Hyper-Convergence can give, then there's another set of customers I'm not making happy.
Right, and then you can address a broad swath that needs the hybrid solution, because they've got local productions they've got to be doing, and it's just easier to have the gear on hand and in your pocket. But then they're doing regional productions or nationwide or worldwide productions, and you got to be able to use all those remote sources so that you've got people wherever they are working on the project.
Yeah. And remember, of course, that REMI can be done with both models. And you can do REMI with a hybrid solution as well, frankly. I mean, you could have operators who are accessing some on-prem equipment as well as accessing some cloud solutions simultaneously from wherever they are, as long as the on-prem equipment they're accessing gives the ability for it to be controlled remotely. And I think that's pretty standard for equipment from almost everybody today, is that, it's IP control typically, right?
Right.
In which case, the only thing you've got to deal with is a little bit more latency. If someone is in, Seattle and controlling equipment in Tokyo, it's still doable. It just means there's a bit more latency on the control.
Sure.
And we know people who did that, obviously.
Yeah. Well, that brings up a good point. There are challenges to both, and we touched on some of them: the amount of cabling, the complexity, the physical size that traditional gear takes. Moving to the cloud, obviously, there's the latency issue and bandwidth accessibility, if you will, for doing WAN productions. What are some of the other challenges that you've seen, and what have you guys done to overcome them?
So one of the big challenges cloud has, let's be frank, is it's just newer. And, for the on-prem equipment, we've had 30, 40 plus years of figuring out the workflows and really optimizing what that means. And cloud is for live production, right? Cloud for getting live video and audio in and out. It's just newer. So some of those issues that we've resolved for the on-prem equipment aren't resolved yet. So you mentioned latency, obviously. That's one of the issues. And on top of that, though, there's bandwidth is a big one. Video in and out of the cloud, right? So obviously, one of the big pushes people liked about 2110. So if you look at 2110, it was, hey, I want to get the advantages that IP gives for video. But almost everybody who went 2110, almost exclusively, went uncompressed. Right? So the second I go to cloud, you just don't have the data pipes. You just don't. I mean, if you look at some productions have terabits of uncompressed video data. If you actually look at it, because a 12 gig signal is obviously 12 gigabytes per second. 12, and if you've got lots of cameras, lots of video servers, that adds up really fast. And if you want to get that into the cloud, some of those sources move to be native in the cloud, though, right? It's because if I'm doing video servers, I'm not going to do them on-prem and ship the video up. I'll instantiate the video servers in the cloud. So mostly we're talking cameras that are physically need to go up, but you still need to generally compress them. I've spoken with somebody. Nobody yet has told me they're actually managing to get uncompressed UHT into the cloud. So at this point, it's compressed. Typical things we see are, SRT. I think is one of the more common ones by far to get video in and out of the cloud.
Right.
But that compression adds latency. And for some people, if you care about the fact that you're compressing your video, you can make some argument about quality being not as good as uncompressed. I actually think that for the most part, the quality is as long as you choose a decent compression, you're actually pretty good. And the layperson will never notice. People who know it really well might, but I don't think people at home will actually notice that. And obviously, we all know that at the end of the day, by the time that someone sees this at home, it's compressed.
Right. Heavily compressed.
Yeah. But one of the challenges here, though, is, with SDI, I used to be able to say, if you give me video, it's one of the big six. There's 720, 1080, the different frequencies, et cetera. That standardization isn't necessarily there into the cloud. Like, which transport are you using SRT? A lot of people like to use NDI nowadays. Right. As we know well, but they're not the only ones. And then even within SRT, which codec are you using? Is it H.264? Is it H.265? Pick your favorite codec vendor. And even within those, there's various settings. And for interoperability, you really want to be able to get video from anybody and receive it. Mm-hmm. And because there's so many different ways you could do that today, you got to be a bit more careful about that. So that interoperability is something on video we're still working it out. And then there's, if we look at 21, I think 2110 is a good place to compare to for the cloud. With 2110, I can use, ISO 4 to tell me all the video signals that exist. Mm-hmm. Where's the equivalent for ISO 4 for video they use in the cloud? And the reality is there really isn't one for broadcast. Video. Yeah. So one of the things that we've done, so Ross Video, we've actually put proposals in front of AMWA on IS4, which is the discovery of video signals and equipment, to extend it to include things like, well, could I discover like an SRT stream somehow? Like, what does that look like? So we're talking with AMWA about extensions to IS4. And the next one is switching. Again, in 2110, there's IS5. I can use ISO 5 to switch video signals. Where's the equivalent that says I can switch? I know that if I've got a control system made independently from someone, that they can switch all the video sources that they know about. And in 2110, that's ISO 5. So we're talking about extensions to ISO 5 to be able to, again, switch all the kind of video that you would find natively in the cloud, including things like CDI. And CDI is, Amazon's way of moving uncompressed video, typically with it between cloud instances. So we're pushing that ability to do that. And then there's control and orchestration, because it used to be equipment was pretty plug and play historically, especially for video. I plugged the cable in, video flowed. But also there's control and of equipment. And again, as an operator, do you really want to sit in front of 8 control surfaces? Like, okay, this is the one that's controlling the video server. Here's the one that's controlling, especially from different vendors. So if there was an easy concerted way to have a control system, or even individual products, see each other, control each other, talk to each other. And we've got a proposal that we've been talking about internally called Katina, which stands for a series of interconnected links. And we've been looking at an organization called the OSA, the Open Services Alliance, which was built around making cloud microservices work better, to be able to control, in a similar way, control equipment from any vendor. Because again, usually you can get control between equipment within one vendor, but multi-vendor solutions, of course, is really a challenge. And also it's what customers want. Let's be honest. I mean, customers want the flexibility to be able to buy equipment from multiple people, not have to be locked into one vendor. Right. And this interop is really what allows that. So we've been working hard on all of those factors, but it's not done yet. And there's work to do still, but we're pushing forward very hard on it all.
What do you think the possibilities are as a result of getting some of these bugs worked out? I was just thinking if we can have auto detection of signal types and compression rates and those kinds of things, and we get better control of disparate manufacturers of solutions. Are there some advanced techniques that maybe can come to buy? Can we apply some AI here and help the TD to accomplish more, have a higher quality of production?
Well, AI is a fascinating topic in itself, and we're only talking, I think, for an hour today. We probably can't go too deep into it. There's we've already released some AI products, and there's a lot of AI actually in broadcast already. Not necessarily in the live production area, but live captioning, for example, right, is an area where AI is quite prevalent, and media asset management, AI for certainly, annotating clips with metadata is quite commonly used today. We're using AI right now within our robotics product lines, camera motion systems is what we call it, to be able to actually steer the robot so that if you shift, like I tend to shift, you probably notice I tend to shift around. Sorry. I apologize to your editor if he's trying to center me in the frame the whole time. It's just my nature. But if you've got someone like me, and I'm doing this, we've got it so that it can actually steer the camera to keep you framed correctly with some hysteresis, so it's not, making your camera shot look terrible. But AI going forward for a lot of stuff has a lot of interesting possibilities. And I think we're only touching the surface of it today, to be honest. I know lots of people are looking into what more we can do in the future, including ourselves.
Oh, that's great. I see it as anything we can do to enable the creatives to remain creative and avoid that technical domain, the better quality production we're going to get. And the tools that we're talking about here, the tools that you guys have developed, I think are just targeted right at that, simplifying the overall operation, consolidating the equipment and the functionality, reducing weight, reducing complexity. All those things go to a solution that makes it easier to build workflows, to change those workflows on demand, and to have a much more elegant solution, if you will. So you spend more time on the creative and quality aspects of the production rather than trying to make sure all those connections are working correctly and everything's behaving right. So
one of the things that I've always believed in is let's let people do the things that people are great at, and then let's let computers do the things that computers are great at. Right. And there's if a computer can do something really well for you, there's no reason to waste a human's time doing it. Let the human do the more interesting things, which is one of the reasons we've developed automation systems for many years. And I think it's worth mentioning the cloud stuff. there's a lot of discussion of, hey, we're going to talk about cloud production. So people talk about putting production switches in the cloud, which is great. We've got a production switcher that we're quite proud of in the cloud as well. But it's more than that. You really want to talk about the entire infrastructure to do with production if you want to talk about cloud production. And it's not just, hey, can I put my server in the cloud? It's can I put my automation systems, my newsroom control systems, my asset management systems? Can we do all of that in the cloud? And that's the direction we're looking at it from, which is not, can I put it in? What does it look like to put a switcher in the cloud? Or what does it look like to put a playout server in the cloud? We're looking at it more from, well, let's talk about putting a production system in the cloud. And that really involves a large number of systems. It's got graphics, it's got playout, it's got the switcher, audio processing as well, et cetera. So I think that's the more interesting way to look at the cloud as well, is not just I'm moving one piece of kit from here to here. It's I'm moving actually the ability to do the entire production plus studio into the cloud.
Wow. Well, this has been an absolutely fascinating conversation. I think we could go on for quite a while.
I was like, oh, we're over?
Yeah, it's gone incredibly fast. Well, Troy, I really appreciate you spending some time with us today. Tremendous talent. And again, kudos to Ross for your development here, and greatly appreciate your time with us today.
Thanks for watching Broadcast to Post. Please make sure to subscribe to the podcast to receive future episodes. Follow Keycode Media on LinkedIn, Twitter, Facebook, or Instagram to receive news on additional AV, broadcast, and post-production technology content. See you next time, folks.